Okay, so how do we do this? First part, 2x plus 3, we know this is a straight line, we know the y-intercept, we did this in 2.1, how to graph any straight line. You go to the, what intercept?
3.
Y-intercept, which is 3, and the slope is 2, so go up 2 and
Over 1.
right 1, up 2 and right 1, and then down 2 and left 1, right? So, but this one, we are going all the values x is less than 0. So, x is less than 0, we can't even think this yet, right? Because less than 0 is this way, so we have to go this way. All the x numbers from negative infinity to 0, but not including 0, not including 0. So, what do you? Go down 2 again, left 1, down 2, left 1, correct? So now we are going to draw the solid line here. What happened when it's 0? When it's equal to 0, x is equal to 0. The y-intercept is 3, but is 0 included in the domain?
No, this is open.
No, so this is an open circle. So you guys, you need to, in this piecewise defined functions, you need to show your open points and close points correctly. I mean, if you don't have that, if the problem worth 6 points, you'll get only 3 points. If you have 2 mistakes, you don't get any points. Very important. Okay? Okay, x is greater than or equal to 0, we have this. What's the y-intercept? 3. This you can rewrite this as y f of x is equal to negative x plus 3 is the same thing, correct?
Yeah.
So y-intercept is negative. When x is equal to 0, when we are doing this function, x is equal to 0, or it's positive 3, correct? So we need to now consider this. Now at this point, because this is a closed circle, right? Because this was open for this one, but is taking that point, this point is covered from this function. You guys see that? So here it's a closed point now, because it's the same point. Now we are using this rule. What is the slope here? Negative 1. That means you go down 1 to the right 1. So you go down 1 to the right 1, down 1 to the right 1, down 1, right 1. So this is the, so these are the 2 graphs that you need to show here. This is altogether 1 graph. Easy, right? We know how to do all type of functions now, because we have covered all type of functions, basic ones, all those 7 basic ones, you know, we have covered. Now in this class, guys, I'm telling you again, please, everybody must know how to do the basic functions, every one of you guys. Okay, know how to graph. It can take even more than 2 minutes, you should know it. Most of you guys did a really good job on 2.1 homework. So this is, you guys have done this in elementary algebra, beginning algebra, intermediate algebra, all this, right? So now we are, question?
Wait, so for 2x plus 3, it says x is less than 0. So do we have to have a point at 0, x equals 0?
Yeah, x equal to 0 because this is 0 included.
Yeah, but I mean for the other equation.
For this one, 0 is not included. So for this one, when you graph, this was an open point. Okay? But this open point was taken when we are graphing this one. So now the overall, the graph, this point is closed. You following that?
So they have to be like that. That's it.
Yeah, we graph this one. When we graph, you know, it's not just like we have Just take one at a time and do the appropriate work for this. This was open, but when we did this one, this open point became what? Closed, because of this rule. Because here the y-intercept also 3. Because we use the same. If this was 4 here, then we go a close point here and this become open. Are you guys following that?
Yeah.
Okay, so this became closed because it was the same point when we graphed this. Question, Betty?
Yes. So now for the second one, which is 3 minus x, and since x is greater than or equal to 0, how come we don't extend upwards because it's greater than 0, not downwards like how you do with the other one?
Yeah, because this one only we are picking x greater than value. We don't go, this is, when you go this way, these are negative values x.
Oh, I see. Okay.
We only pick x greater than value, I'm using this red.
Okay.
X greater than or equal to 0, all the value this side.
I see. Okay.
We can't pick, when we do this graph, can we pick x negative number here? We cannot pick it's not the domain. You need to use the restricted domain. By saying this, what it's saying is this is the restricted domain. So you need to, you guys have heard this word a lot of times now. So focus on the corresponding domain for the corresponding rule.
Okay.
Okay? Is that clear? Okay. So if you have like this or this, it's wrong, completely wrong. Question?
So if you have anything where it lies on the same point, and then one is less than and one is less than or greater or whatever,
Yeah.
then the closed one will always basically take over.
Yeah, close one is, it is taken. We have to put the close because one is open, the other one is closing. So the whole function is closed there. Okay? Okay. So in other words, what they're saying here is we are picking all the numbers when x is from negative infinity to positive infinity. This together, the domain says all values, all real numbers for x, correct? Okay. Okay, so let's do one more example. And I want to do the one with 3 functions. We have one with 3 functions. Okay, 64. Let's do 64. This is a good one. 64. This is also a homework problem, but that's okay. You guys, when you redo this problem, make sure you don't look at the notes, redo it, and then see whether you can take the same. Okay? I'll do the same problem here. 64 f of x is equal to, we have 3 here, correct? 2x plus 1, 2x plus 1, 2x squared minus 1, and we have 1 minus x squared. One minus x squared, correct? So guys, so now this one, x is less than negative 1, x is less, 64, x is less than or equal to negative 1, x is in between 1 and negative 1, and x is greater than 1. Okay, so we need to, I put a colon or comma here just to separate the, now these all 3 together one function. Okay, so we need to work on first one, first. What do we have? A function, straight line, right? What are the domain numbers we are picking here?
Or negative 1.
What's the domain numbers?
-1 to -infinity.
X supposed to be less than -1, right?
Less than or equal.
Less than or equal to, -1. So we have to go to the domain x is less than or equal to -1. This is -1. Less than or equal means taking equal sign. X equal to -1 is in the domain. So what's the slope? 2. So what's the y-intercept?
1.
1. Y-intercept is 1. Right, y-intercept is 1. But y-intercept 1, we are going to mark this, but y-intercept means x equal to 0, but it's not part of the function, right? But we are using this y-intercept to just to graph the other part. So I'm not going to consider, I'm just like making a mark here. Okay, what's the slope here? 2, that means go up to, if you go down to, yeah. So from here, go up to, and what? Over 1 to the right. Up to over 1 to the right. So go up to over 1 to the right. When you go 1 to the right, it line up with -1, right? So this is where we are going to start. Okay? Or you can say, what is when x equal to -1? Substitute to here, what's the y value? -2 plus 1 is? Oh, we went down, sorry. 2. So you go up 2 to the right, right?
Yeah.
So it's coming here, but let's say it's -1 here, what happened?
Minus 1. Negative.
-1, correct? So -1, so here is -1. So this is 1 point. When x is, we can only start with -1. What's x is -2? You can do the mental math. What?
Minus 3.
Huh?
Negative
-3. So you go down 3, -2, -3. Here?
3. Yeah.
X is -3, what is it?
Minus negative 5.
-5, -3, -5, right? So this is the graph. Is this point included? Yes, so this is included. Included means you have to make a solid graph. And this line is going all the way down. That's what this arrow means. Okay? Everybody okay? Now you guys also know why we did not put any continue this graph all the way like this. You guys know. Right? What's the reason? What's the reason? Can you say that to me in like more detail? You guys have less than equal x. What is, can you explain it to me in more detail, Matthew?
The domain is less than or equal to -1.
Very good. Domain values is supposed to be less than or equal to -1. So therefore we cannot pick any numbers greater than -1 for domain. If we can't put any negative greater than -1 for domain, we cannot use the y value for that graph. Remember that machine thing?
Yes.
Whatever you put only you get an outcome.
Yes.
Whatever you input, there is an outcome. Here we cannot input these values here because it says restriction. You cannot do that. In real life, you go to a company, in real life, in this community college, there are a lot of restrictions, so we need to focus on those restrictions. You cannot use those. Okay? Alright, so what is this now? Now you guys know this is a quadratic function. You know how to graph quadratic functions. Okay? But using this domain. Using this domain. So we have to quickly know how to graph. F of x is equal to what? 2x squared minus 1. What's the domain?
0.
Domain is all the values, x supposed to be all the values of what? Negative 1, this is included?
No. No.
It's not included, this is included, correct?
No.
So,
No.
You didn't write it like that, but what was it?
That's what it is in the book.
do I have that right?
It's -1 less than x less than or equal to 1. So
Oh,
there should
okay,
be,
so this is then like this, right?
the x is less than or, no, the next one.
Yeah.
Yeah, so that should be
Equal.
equal, less than or equal to.
But this one equal?
No.
Yeah.
Oh, yes, sorry.
Oh, okay, sorry. Okay. So now within this interval, guys, pick up the numbers, like whole numbers. What are the whole numbers we have for here?
0 and 1.
0.
X, so if we do a little chart here, x equal to what?
0.
We can pick 0. Can we pick -1? No,
No.
right? X equal to 0 and
1.
1. X equal to 0 and 1. So now when x equal to 0, just substitute this, what do you get?
-1.
-1, and x equal to 1, what do you get? 1, right? So we have these 2 points, okay? We have these 2 points, but this is not a straight line, we know that, right? What kind of graph is this? Is this going down or this is a parabola? Remember we did graph ax squared plus bx plus c. This is a parabola, so it's going upward because of a is greater than 0. So it's something like this, right? Right? So we need to know exactly where the vertex is. What's the vertex? How to find the vertex? Remember we did this. Now this is, guys, you don't have to show the work for this because we are assuming you already know this work. So you can do the stretch work, how to graph a quadratic function. I went through this real detail, 4 ways of picking 4 ways, right? What are the 4 ways? You find the vertex, find the x-axis, find the, Find the x-intercepts, right? Find the y-intercept, find the vertex and use the axis of symmetry. You guys have done that a lot. So what's the vertex here? Vertex is negative b over 2a, correct? So what is it? b is 0, right? B is 0 because x term is not there. A is 2, so we get 0 over 2. A is, so anything divided by a is 2 here, so this becomes vertex is equal to 0. So vertex is equal to 0. What's the y-intercept? Y-intercept is -1. X equal to 0, y-intercept is -1. So the vertex is
0.
0, -1 included, right?
Yes.
And then, so this is the vertex, and then we have our 2 points, correct? 0, -1, 0, -1, and 1 and 1. 1 and 1. 1 and 1, correct? So now, through the vertex, we have the axis of symmetry. Remember we talked about that? Right? So this is the vertex. Always get the vertex when you graph this quadratic one. Okay? Through the vertex, we have axis of symmetry. Use the axis of symmetry to pick the other points. Now we are only considering these 3 points here. So the graph is going through this and the graph is going through 1, 1.
Yeah.
Here, where else the graph is going through? If the graph is going through here, this is the axis of symmetry, and then there should be, the graph should go through here as well, correct? -1, 1. Graph is going through here too. Now, we have to make sure when the is negative 1 part of the domain? No. But it goes all the way up to there, but it doesn't take that particular point. So what do you need to do? Open circle. So we are going to make this open circle. This is a lot of work to consider here, okay? But if you know how to graph a quadratic function using axis of symmetry completely without spending a lot of time, you are very good. Only thing you're going to get behind, you're going to, spend a lot of time when you don't know the previous work. So here, what are you going to do? From here to here, we're not going to do a straight like this thing, right? Are we going to do this? No, because we know when you graph x squared, it's a smooth curve, parabola type. Every time you graph x squared, it's a parabola, going up or going down. So if you do this, it's not right. So here we are going to do from here to here, here to here. Oh, sorry. Okay. Is this point included? Yes. So now we need to include this point. This is an open point, this is a closed point. So this part needs to be graphed really carefully, guys. Very hard. I mean, this is like a lot of work you need to think. Okay?
What would this domain be?
Domain is -1, 0. All these numbers in between -1 to +1. +1 included, therefore this is closed. You see that? Everybody see that? Okay? Okay, what do you have next now? So this is my sketch work. I don't even have to see this. As long as you're doing this, that's all I need to see. You don't have to show me the sketch work. Why? Because I know you guys know how to graph a quadratic function. Do you have to show me the table of ordered pair? No. Because the problem is graph this piecewise defined function. That's it. We are not checking on your other stuff. Okay, so the next part is, what's number 3? Oh, it's also a parabola, right? It's also parabola, but this is, so you can look at this separately. If you have something like this, 1 minus x squared, we are going to rewrite this as -x squared plus 1. Okay? What values? What's the domain? This is f of x. What's the domain for this? Domain is x is greater than 1. 1 through infinity. Including 1? No, not include. So this is the domain. So we can pick all the numbers, but not from 1 through, not including 1. But we have to use 1, right? When x is equal to 1, what happened here? This is 1 squared. So let's pick some points here. We are going to use 1. This is x, this is f of x. When x equal to 1, we get negative sign here, 1 squared here, plus 1. So this is -1 plus 1 is 0. When x equal to 1, y value is?
Wait, -1 squared when that equals 1.
So do 2?
No, x equal to 1, right? We are not picking x equal to -1.
Yeah, but there's a negative.
Is negative included in it or is it?
Yeah, but this negative sign is out.
So you add that after you subtract.
Yeah, it's not like this. Negative x, if you have like this, then it become positive.
Yeah.
So what this means, -x squared means negative sign like that and x squared like this. Okay, so what do you get there? When x equal to -1, what value we have? Y is equal to 0. I mean x equal to +1, y is equal to 0. So x equal to +1, this is the value. Y is equal to 0. This is open or closed?
Open.
Open. Very good. Very good. So make sure that this is open. So when we know So you don't even have to show me this algebra here, all you have to do is this, right? Okay, so we can pick x equal to 2. What's the x equal to 2?
-3.
2 square, -3. X equal to 3. -8, right? So you guys know, so these values, x equal to 2, -3. 1, 2, 3, -3. X equal to 1, 2, 3, x equal to 3, -8. So somewhere here. Right? Okay guys, what is the vertex here? What's the vertex? Vertex is, x coordinate of the vertex is -b over 2a, b is 0, correct? So therefore 0 divided by any number is 0, so the x coordinate of the vertex is 0. When x is 0, what's the y value? 1, right? So the vertex is 0 and 1. So this is how we find the vertex. First we find the x coordinate of the vertex and then we find the y. So 0 and 1 is the vertex. 0, x is 0 and 0 and 1, right? So vertex is not part of the domain. If you consider vertex, that vertex, x is 0, we are not supposed to even use it. So we don't have to make the vertex in this problem. Because vertex is not part of the domain. So now we know when we have to graph these 3 points connected, are we going to make a straight line? Why? Why we are not going to make a straight line? Because this is a quadratic. So there's lots of information you have to know in this problem. You have to know really well how to graph quadratic and how to use the restricted domain. A lot of work. Okay? So here this one is going to be, now think of this, the vertex is coming from here, right? So it's not like this, you have to graph it like this is the vertex, okay? But don't draw the line there. You see what I mean? So here, like this, you see? It's going upward here, but this point is not there. It's going through here to be the vertex, but it's open. Everybody understand this? A lot of work, guys, but focus on this, okay? You can do it. All you have to do is consider the restricted domain. Consider the restricted domain. See, I didn't have to use the vertex here. I can't use the vertex because for this rule, vertex is using a domain value that we are not supposed to use. Okay? Then graphing this one. So what you're doing is graphing 3 functions. 3 functions as one function. It's like within the department, there are 3 different operations going using different rules. You see that? That's the same concept here. Okay? So guys, now with my experience, I'm not trying to make it negative about this here, make a negative statement, but I'm letting you know sometimes I do say things, it sounds like negative, but I don't want you to take it that way, okay? What I'm saying is for you to be aware. Okay? So you to be aware, what I want to say is with my experience, when I grade this, people are not doing that good. Students are not doing that good on this problem. I think you guys can do really well. I did 3 examples, you know exactly what to do, your study, you will be good. Okay? So, so this is going to be one of the test questions. There will be one of them, not 2. I will put a quadratic one, at least with 2 of them. I'll have 1 quadratic and 1 straight line. Last class meeting what I did is 1 quadratic and 1 straight line. Okay? This one I did 3 because homework you have a couple more problems where you have to do with 3 functions. Okay? Okay. Any questions from this? Very good. Okay, so that part we are done. Gosh, the time is flying in this class. I'm getting nervous because I need to cover so many things and I'm looking at the time. Okay, so 2.3 we covered. What did we cover last class meeting? 2.3. We discussed properties of functions, and I think we wrote about 6 of them. 6, 5, 9. Oh, we did go because I wrote each one separately, right? I wrote like. What was the last ones we did? I wrote even I wrote separate, odd I wrote separate, right? Yeah. And we did some examples, so we will cover more examples today with that. And also, I think I need to cover one last thing from 2.3. One last thing from 2.3, I need to cover maximum, page 204, relative maximum and relative minimum. So properties of functions. So we covered 9 of them?
No.
9? Okay, so this is number 10 then. So, relative minimum, number 11 is relative maximum. Okay. So the definition in your book says a function value f of a is called the relative minimum of f if there exists an interval x1, x2 that contain a such that x is in that interval let me explain this, you guys using the same definition. Okay, this is a little abstract the way the book is saying this, but when I draw the diagram, I'll explain it to you, you'll understand this, okay? So once when you read, if you are not understanding the whole concept, it's okay, okay? So let me write this first and see whether we can follow the definition. A function value f of a function value Now what is f of a, guys? The function value f of a. What does this mean? What is f of a means? Function value f of a.
The y.
That's the y value. We have talked about this. F of x is a y value. That's why it's called function value. So in here, when we say function value f of a, when you see something that you know it means the y value of a graph. Right? Okay. Is called the relative minimum of f, relative minimum of f. What is this f means? Function name, right? F of x is the, f is the, remember, this is the function notation. So, of f, if there exists an interval x1, x2. There is this open interval that contain a, that contains a is the domain number, a comes from the domain, because f of a, right, that contain a in that little open interval, such that, now there's a condition, such that, what does it say? F of a value has to be less than or equal f of x. I'm going to write some other, for all x, this part is not in the book, but I'm going to write this, right? For all x values in the interval x1, x2, like this. For all the x values, f of x has to be, f of a has to be greater than. F of a is the minimum value. So in other words, it's like this. It's like this. Let me graph here the minimum. So let's say a graph is going like this. Growing like this, going like this, going like this, and going like this. Okay. Now, let's take an open interval in this function. This is a function, the whole graph. Okay. So there are, this is the y values, there are extremely bigger y values here. Do we care? No. There are bigger y values, right? Function values. Y values are function values. There are way smaller function values, right? Because it's going like this, they can be very small function values, but we don't care. We are only caring about a given, within a given interval, a small interval, is there a minimum value, a small value?
Yeah.
Than all the other y values. So if you take this interval, within this interval, so the x values are from here to here, so this can be x1, this can be x2, see? This is the y value, right?
Yes.
Within this interval there exists a is in part of the, A is a relative minimum, A is a relative minimum, A is a number and it's a relative minimum. It's not x here, A is a number, A is this. It's a number. This is A, the y value. And that y value is called the relative minimum. Okay? That y value. Oh, I'm sorry. In this here, f of A is here, okay? A is here, and this is f of A. And this is f of A. You see that? There is A here, there is a here, and this is f of A. F of A is smaller than all the other x's in this interval. That's what I wrote this part, because this part was not in the book. Okay? You see, if you get f of x here, this f of x value is greater than f of A, correct? This f of x value is greater than still f of A. F of A is the smallest. Are you following that? Only within that interval. But there are, in the function, there are smaller values, many. But within that given interval, this f of A is the, what?
Minimum.
Huh?
Relative minimum.
The smallest. Within this given interval. So, f of A is the smallest. So, this is why f of A is the smaller than all the other f of x's in that interval. It's little abstract, but it's not you can understand this, right? So, we call this what? Relative minimum. So, this is relative minimum, this point. So, let's say we have this A is 3, and we got the function value to be this is 3, this is negative 2. So we are supposed to say like this: the relative minimum is at, because that's a value, we don't say give a point. When we say relative minimum, we say what? F has a relative minimum at, F has a relative minimum at
3.
So how will you say? So looking at this, we are going to say F has, for this example, this is with the definition. So if we are saying this with the numbers, we are going to say F has a relative minimum at what?
3.
3 negative.
At,
-2.
F has a relative minimum at 3, no, negative 2, right? Negative 2, if has a relative minimum at negative 2, that means the y value. For x is equal to, or at x is equal to 3. At x equal to 3. F has a relative minimum of, I'm sorry, we have to say of here, of negative 3, sorry, negative 2 at x equal to
3.
at x. So you guys need to underline this. This is how we talked about relative minimum. Relative minimum of, because this is the value we talk about. Relative minimum is a y value. Relative minimum of negative 2 at x equal to 3. You need to say it like this, not like the ordered pair. You need to look at the ordered pair and read like this. Are you okay with this?
Yes.
Okay. Okay guys, I'm going to move on to the next. What's the next definition? Number 10. A function. So I'm just going to number 10. Everybody good? Okay. So now I'm going to write number 11 to be this. You guys need to rewrite this. And the number 11 is relative maximum. Call a relative max of f if the x is an interval x1, x2, this is an open interval that contains a is in part of number in that interval, right? A is a number in that interval such that where is the other part I wrote? Oh, I did not write this
No,
part.
it's under the graph.
Huh?
It's under the graph.
I erased that, right? I'm sorry guys, such that I need to write this x. So this is x1, all x's are in between x, that's the same thing I wrote here, okay? All x's are in between sorry. So guys, so I did write this in here, okay? It's the same thing the book says here. All x's in that interval. All x's within this interval, that means all x's in this interval. Where's the interval? This interval. In this interval there are a lot of x's, that's what this means. Okay? X is in between. For all that f of x value, here it says f of x has to be greater. Here, when this is a maximum, we have to say f of x is, f of a is greater than equal to f of x. Okay? So, it's the same thing. So you guys, relative max here. Okay, so it's the same thing. So what it says here, so you guys need to write the definition here, okay, and include this, and we are talking about what now? Relative max. So when we have a graph, like this, this graph can go all the way, there are bigger values. But if you take an interval here, within this interval, we are going to call this as x1 and this as x2. There are lots of x's in this interval, that's what this means. Within this interval, there is also called what value? A. X is equal to A. That point is here. So this point is f of A point, the y value, evaluated at point A. That y value is greater than all the other y values around that interval. You guys see that? So that's what this definition is saying. So when you are reading the definition at the beginning, it's extremely abstract. I know how because I remember when I was doing this long time ago, I'll read it and I will not understand this. I have to read it again, word to word, read it again, and really look at it carefully to understand the wording part. See, there's lots of story here. You see that? Every little tiny word is very important. because they're talking about function f here, see? Right? That's the graph that they're talking about. F of a is the value. It can be a maximum in first case, second case, this case, the other case it's a relative minimum. So this f of a value is a relative what? Max. So this is a relative max. This is the relative max. Relative max. So this definition says that f of a value within all these intervals, this all x values always have to be greater than all the other x's around. Are you following that? Only within that interval. So if you take any number from this side to this side, so which is a relative max. But there are other maximum values of the function. We don't care. We only talk about relative max. Do we have another relative max here? A same function can have more than one relative max? No. No? Yes, right? How about here? This is another relative max. Right?
Okay, so just anytime there's a peak.
Huh?
So anytime there's a peak, you can show as like.
Yeah, anytime it's a peak, it could be relative max or relative minimum. Question?
So that goes the same for the relative minimum, there could be two relative minimums then?
Yes, you can have more than two relative minimums.
Okay.
We are going to talk about absolute max, absolute min, but so this book, we are not supposed to cover that for now. That means within the function, the absolute value of the biggest y value. That's called the absolute. Okay. So we are only talking about, so there are two or more relative, there can be always one relative max. I mean one or more, or even none, right? There's no peak, there's no relative max or relative min. Okay? Are we good with this? Okay, alright. Erasing. Any questions with these guys? You guys had good questions, good. You guys said, so when you have a peak, look for relative max or relative min. Okay, now I'm going to put numbers of this. Let's do this. Example. So we have I'm going to have, this is at 3, this is at 1. So what is this point?
Relative maximum.
1 and 3. So how will you going to say this? This graph, f has, so we are going to say what?
Max.
Yeah, we are going to say, how will you say? F has a
Relative maximum.
relative
Maximum
max
of 3.
of
3.
3, right? Of 3. That's the relative max value. The relative max of 3 at x equal to 1. When x equal to 1, there is a relative max at 3. Relative max is 3. You can say also that like that. When x equal to 1, the relative max is 3. But usually this is how we say it. Okay? Yeah. Good. Okay guys, so we did this. Oh, we are done with 2.4. 2.3 we did all. I need to do a couple more examples before I go to 2.4. 2.4 we are basically done. I need to do okay. So odd or even functions or neither. You guys know how to do odd even functions, right? We did some examples. let's do, I'm just going to do a couple more examples. This is from last class meeting. So how many properties we have discussed? Properties of functions? 11. All these questions are on the test. Okay? Okay, so the next thing is more examples on determining if the given function is odd. So we're going to say odd. So if you say here, graph the even, odd, or neither. Some functions are not even, not odd, then we call it neither. Okay? So let's do a couple of examples. Which one? I'm going to do 95, x squared minus 4. Now, I did an example similar to this, right? Number 95, x squared, f of x is equal to x squared minus 4. I did one similar to this, I'm redoing again. So whenever we are asked to find even, odd, or neither, what do you need to check? Remember we did one, I showed it to you guys numerically, right? That all values, what's the condition that's satisfied?
Yes.
So what's the definition says to satisfy?
4.
F of we are checking for, we need to look for what? When we are checking for even, we need to look for? So I'm going to write the notes here. For even, f of negative x supposed to be
Equal to f.
f of x. If you have this is even. This case is even. If we can convert our formula to this to be look like this, that's even. What's the odd case?
F negative x equals negative f of x.
If we can get this case, it is the odd case. If we can't get this one or this one, then we say it's neither. Okay? Okay, so let's work with this. So always you have to keep in mind that we are going to look whether the function is odd, even, or neither, right? So let's check for odd first here, or even first, right? What do you need to check for when you're checking for odd or even? Doesn't matter, what do you need to check for? Whenever we are checking for odd or even, what do you need to do here? Plug in instead of x, what are we going to check for here?
Negative x.
Negative, always check for negative x. Even for even case negative x, odd case also negative x. You see that? So always check for negative x. And if we can come up with this, we can't say even. If we can come up with this, we are going to say odd. So check for negative x. F of negative x is equal to negative x whole thing square. This is x square minus 4. Negative x whole thing squared is x squared minus 4. What is this now? What we are getting when we do the evaluate this, what are we getting?
The original
At
problem.
the back.
This whole thing is f of x, right? So this is f of x. You see that? So what did we got here? F of negative x is equal to f of x. We can do this algebraically. This is what it shows algebraically, not numerically. Okay? We need to show this algebraically. Convert, substitute this and just do some manipulation here or simplify this. See whether you can write f of x or you can write this as negative f of x. Okay? So what do we have here? So therefore this is a even function. So this is an even function. Okay? You have to show this work. Now, let's do one more problem from here. I think I did about 3-4 problems last class meeting. f of x is equal to 5 minus 3x. I think this is problem number 94. What page? 209. Okay. What are we checking? Odd, even, or neither, right? How are we going to check odd, even, or neither? Algebraically? Plug in negative x and evaluate the function. F of negative x equal to 5 minus 3 times, what is here? Negative x. Right? When we do this, what do you get? 5 plus 3x. Right, guys? Okay. 5 plus 3x, can we write this as f of x? No, we cannot write, so it's not odd function. I mean, sorry, it's not even function, right? This we cannot write as what? F of x, right? Because f of x is this. But if you pull out a negative sign now, we need to write this as negative 5, negative 3x, correct?
Yes.
Now is this f of x? No. So this is not f of x either, with a negative sign now. Do you guys see that? Can we put f of x for this one? If you pull a negative sign out? No. So we cannot write this part after you substitute negative, evaluate for negative x as negative f of x or positive f of x. Are we following this? So we cannot, this is not f of x, this is not f of x, this is not f of x. So we can't do this, we can't get the f of x. So this is, if you work with this, f of negative x is not equal to f of x in this case, or f of negative x is not equal to negative f of x in this one, if we use this function. Therefore, this is not a even function or this is not a odd function. Therefore, this is neither. You guys, you're good with this now, right? So all you have to do, remember I did the x to the power 3 1 last class meeting? X to the power 3 1, we considered it as a negative, we pulled the negative 1 out, right? And algebraically showed that f of negative x is equal to negative f of x. Right? Remember we did that really fast? Come with an example for me. What was this? Let's do another example. F of x is equal to, let's say, 2 minus x to the power 3, something like this. I think I did something very similar to this, right? So this one, what do you need to check? F of negative. Always check for f of negative x. That's it. 2 minus negative x whole thing to the power 3. 2 minus this become inside negative x cube, right? If you drop the parentheses, it become this. Right, guys? First drop the parentheses. This becomes what?
Plus x cubed.
So this become what? What is this one? So if you pull a negative one out, so we know that this is not a
It's not even.
Not even.
even one because we cannot write this as even function, correct guys? Because this is not f of x is this, okay? Can we pull a negative one out? Then this is negative 2, negative x cubed, correct? But this is not what we have,
No.
right? So in this case also this is
Even.
neither, okay?
Yes.
Okay, we are good. We are good.